I think we might as well get started. It's a 2-hour session, but I'm pretty sure we can get this done a little quicker. I'm not going to focus. I mean, this is essentially an edge case. There are situations where you have certain libraries in Python that you might want to use in R, and maybe you aren't that familiar or that comfortable with using Python in general, and that's where using Python in R actually comes in. So we're basically going to focus on a quick introduction to Python and R, which I guess everybody's really familiar with, but it's just going to be a quick primer before we get into the actual reticulate package. Reticulate is the R package that lets you run, or essentially acts as an interface to Python environments or Python code in general, lets you run Python code inside R. And this is an interactive session, so I would like everybody to try and participate as much as you can. So you will be installing Python in RStudio. And so I would suggest you might want to go ahead and request your instance now if you have RStudio or Grafana access. We might go through some code examples and just general guidelines on when to use R and when to use Python. So I've tried to make this beginner friendly, trying to have some tasks in here as well. So I will be giving you guys some time to look at tasks. Also be giving you the opportunity to just drop in questions in the chat if you feel like it. Whenever there's like a lull or a gap in the actual presentation, we can just take a look at the chat questions and maybe try and address them. Right. So just some housekeeping in general. You might want to go start your RStudio sessions right now if you don't already have one running. And make sure you're using the BII partitions. It's something that has been brought to my attention recently, that most people are using the standard partition, and that's leading to some delays in your startup process. If you don't have RStudio, or if you don't have Grafana, you can just use your local RStudio to follow along. And if you don't use RStudio or R at all, I'm not sure if this is going to be a fun or useful session for you at all. Right, so I'm hoping everyone can get started on your RStudio sessions. While y'all are doing that, I can give you a quick introduction to an important point that I'd like to emphasize. This is A, my first time teaching an online class, and B, when trying to actually run this code this morning, I had this up running and then I pushed it up to GitHub so that you guys can get access to the code as well. Some amount of, a few things went wrong. Murphy's Law is in full effect at the moment. And so in the words of Bill O'Reilly, we're kind of doing it live right now. Using Python in R is a slightly fiddly process. So I feel like this is ironic and poetic at the same time, that we are going through some issues. Lara, are you okay?
She's talking to an animal.
Oh, okay. Right. So while you guys are spinning up the instance, just going to do a quick intro on R versus Python. Most of you guys are using Python occasionally, but R most of the time, and that's generally because academia does focus a lot on R. And that makes a lot of sense because R specifically has a community and also a good number of like well-developed libraries for very specific data analysis tasks, whereas Python is more of a general programming language. And this stuff is always changing. Like just a few years ago, before RStudio was a thing, using R was a completely different experience and honestly a lot less enjoyable. I think picking what language to use in what situation really depends on A, what you are trying to do with it, and B, what the people around you, your local community, that is people in your workplace or in your team, and also your global community, that is people in your field. if they're all using a certain language, you're going to start to see that those libraries or those features of that language are going to get more optimized towards certain tasks. And if a lot of people are using that, the more community support rallies around a certain language, the more the tendency is that that will become the standard to pick. At the moment, though, the Stack Overflow survey for 2019 mentions a 39.4% of professional developers use Python, and 5.6% of them use R, which, I mean, that practically translates to the fact that if you're going to look for answers on Stack Overflow, you might tend to find more content when it comes to Python rather than R. Whether that's important to you or your task specifically, variable. I would like everybody, if you have your session spun up, like if you can just do a yes on the Zoom reactions, that'd be great. Right. R, what is it good for? So that's, again, the only reason I have the slide is mainly for that song reference. But specifically coming back to the question of community, because open source software in general is community driven, if you have certain groups of people adopting a technology, it's going to get better at those specific tasks. R is just the dominant language for clinical research and biostats. It's really good at graphs as well, like the ggplot2. I mean, there's literally wrappers for ggplot2 in Python. There's nothing like really as good so far in Python natively. Right, so that was just essentially some waffling, so you guys get some time to start your sessions. Now I'm gonna put the code in, just gonna put this code in the chat so that you guys can access it. And in the case that you're having some, in case you've forgotten how to get, wait, what? A 404 error. Okay, so that's interesting. So it's possible that you guys aren't part of the DSPG Young Scholars Program. So I'm just going to make this public. Try and right. So try again. So just walking through this again, you can just go to that repo and clone it. And if you've forgotten how Git cloning works, there's a quick little bit of training material in the training folder. But okay, if you don't have that, there's a link as well, just in case you guys need a refresher. And of course, because the reticulate package is what we're going to focus on, you are also going to want to run install.packages reticulate to make sure that It's up and running, working, and we can move on. So what is reticulate? So the quick explanation is that R essentially is an interface. R is a language that's built on interfaces. R itself sits on top of C++. C++ does all the heavy lifting essentially, or all the like real work, while R is an abstraction layer that helps you access those functions a little easier. R Studio sits on top of that to try and make the process of using R even easier. So now in theory, since you can actually have it, since R does interface with C, you can theoretically interface with other languages as well. And that's what Reticulate does for you, where it provides you access to a Python environment in a very similar way. So a lot of R packages actually do stuff like this in the background as well. So this is actually a very common design paradigm for R packages. So Selenium has Java on the backend. There's the Shiny dashboard, which are a lot of JavaScript involved. And so this is really a common concept of interfaces, but this is one of the few cases where you actually can use your own handwritten code and then run it inside one of these R interfaces. So, right. So I'm assuming at least some of you guys have been able to import or like install Reticulate. If you can hit yes on the chat. Okay, I'm seeing some yeses. And this is an interesting time to actually bring up the fact that I had a pretty big crash on Ravana a couple of hours ago, and which is why I will be following along along with you guys. Oh, don't worry. Okay, Andrew just asked a very important question. What's the path to our Python environment on Ravana? You don't need to worry about at the moment. You don't need to really worry about that because because the thing is that using the default Python package or the default Python environment is fine, but I would like everybody to be using Miniconda because I would have a lot of the packages inbuilt so that you don't have to just keep going back and forth and installing packages. And so the steps that I have outlined and the stuff that's in the code should walk you through that process. Does that answer your question, Andrew? Cool. Right. So I'm also at the same time going to pull up right. Again, like yeses in the participant list if you can see my RStudio. Cool. So you can see that I'm in. So I've been able to run these lines: library reticulate, Python run string, import numpy with np, run string, my Python array, and then just making a default Python array. The reason I've gone with this is because NumPy is not something that you have in your default Python installation. That kind of forces Reticulate to start looking at other options, and so it gives you the option to install Miniconda. At which point you can go yes, and then it'll take a minute, but you're going to get Miniconda installed on your system. Well, that didn't work. As is the tragedy of doing things live, occasionally things do not work. So I will be bringing up my alternate system. which is ironically enough in Jupyter Lab. So just for reference, this code should work for you on RStudio. I'm having sessions issues with Ravana, which is why it's not working for me. And so my workaround has been to use our code inside Jupyter. Okay, just sorry, I got a chat message. So just need to take a look. When working in RStudio, not script, would you use? Andrew is bringing up the point that Reticulate in RStudio wasn't working earlier. So ironically enough, it was working for me until this morning. So which is why I would like everybody to give this a shot and see if this is just me or if it's something that's common. And if it's something that is happening to everyone, then that's definitely something that we need to talk to Ravana folks about. And also you can do like I do and get onto Jupyter Notebook instead, use an R container or use an R environment to run Reticulate instead. No, I do not mean Markdown, actually. There is the option to do to run Python chunks in Markdown, and that's not really what I'm trying to illustrate here. I'm just trying to right. So I'm just going to finish Crystal's question first. We're not like, at least the code that I'm writing isn't really about doing Markdown chunks. We're just doing lines at a time as an illustration. And to open an R container, Martha, is you go plus, and you can see notebook options, and you have R 4.0 right there. You can click on that, and you just start a new R. So that's that has been my workaround, and it's worked for me fairly well. And so we can. So I'd like everybody to take a minute to actually try this out and let me know in the chat whether or not it's worked for you. And I mean, try this in RStudio. Do not try this in Jupyter. I have to do this because it's a workaround. But try it in RStudio and see if it works. That is the process of running the first 2 lines until this point and installing Miniconda. Timer. And we're going to see if people are able to get some stuff working. It's installing Miniconda. Right, okay, cool. So while that's happening, everything's working, running RStudio local. Can't install Miniconda, right? What is the error that you're getting when it says can't install Miniconda? Is it something like cannot install Miniconda into a into a path containing spaces, right? Yeah, this is an issue where so Linux is okay with file names that have spaces, but when you're trying to do this in Windows, it makes errors. So my environment also has the same issue. If you look at your path, right, you're going to see a space somewhere in the somewhere in your path. For me, there's a nil space k, which is why it messes me up. So the workaround for that is to set your path, or is to install Python to a specific path and then use the use_Python function to specify what path it should be in. That's a bug. And again, coming back to the question or coming back to the point that running Python in R is pretty fiddly and stuff like this does happen. Not sure. It's no real good explanation for that, but yeah. What is this? Like, what is Miniconda? Essentially, Python 3.8 is your base, or the latest version of your base Python language. Anaconda is a platform which is really every good, stable version of all the most popular data science libraries are all put into one environment, so you don't have to sit and install each and every one of them. So that makes it, and oh yeah, the really handy thing is the Conda package manager. So essentially, pip or Python pip has every, it has very questionable kind of like testing for new or updated packages. So if I wanted to put up a new version of a package that I already had, I could just make changes and submit it. Conda, on the other hand, will have a community of people checking to make sure that this is actually stable and working, and it doesn't have any like massive bugs that might actually affect your workflow. So very often, it's probably a better move to use the Conda package to the Conda package manager to install libraries rather than using pip or PyPy or whatever. But then it's also like 250 packages by default in Anaconda, which is kind of a lot. It's a pretty big, and they keep adding new ones. So it's a pretty big space investment that you don't necessarily need. So Miniconda is the same thing, but mini. So it's just the essentials that you actually need, which is NumPy, pandas, and even this actually takes quite a while to install, as all of you can kind of notice. So Anaconda is a lot bigger, which is why we decided to go with this instead. I'm gonna actually bring up the Anaconda homepage just to show that off a little bit. The individual edition is an open source collection of tools, essentially. So you can just download it from here, and it has all of these things by default implemented in it. And also it gives you a head start on things like TensorFlow and scikit-learn and PyTorch. It's just automatically installed. So yeah, if you are considering using Python more full time, this is something that you can just install for your local machine. But yeah, in its current form, it might be too big to be putting onto our remote systems. So I'm gonna come back to the PowerPoint. Right. So again, because this is my approach to how I learn things, is I need to be able to find a situation that I need the skill for and apply it for that. And so I'm trying to introduce you all to a problem that I'm trying to solve as part of the DSPG for one of the projects, which is converting PDF to Excel, or PDF to a format that is readable, like a data frame or something like that, that's easier to work with. So essentially I have a data set, which is a table, but it's in the PDF format. So how do I get it into an actual data frame so I can do some work with it? Theme specific, and this is something that you run into a lot with government data. Occasionally they will switch it, they will put their data in PDFs, so it's actually harder for people to automate processes of reading government data. Now, I'm not trying to say that they're making it difficult on purpose, but it does feel like that sometimes. it's also a very specific problem to the point that you can see this actual publicly available data set that I took a screenshot of, which is the value of tracts of land, lots, timber, buildings, and improvements, yada, 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 in the county of Accomack, Virginia, which is a relatively rural county in Virginia that we're trying to get the property tax data for. What's interesting is that property tax data is usually just accessible by the general public on county websites or government websites for specific states and counties. But then very often, and you have some counties that just make it really easy for you to just ingest data. And then you have other counties that don't make it. I mean, they make it available technically, but this isn't a format that's actually easy to use. So they are fulfilling their obligations of making their data available, but they're also making it just hard for people to do any analysis with. So R has a library for this, which is called PDF tools. And I've tried running this. I've tried installing PDF tools on Rivana in my R Studio, and I had a bunch of dependency issues. And that's because, like I mentioned earlier, a lot of stuff in R actually has interfaces with other languages. And PDF tools specifically has certain dependencies that on Rivana, we don't have the authority to install. You could probably do this on a local machine, and it's a lot easier. But since we are discussing for the DSPG context and for like a more large scale situation, because my local machine is not really good enough to do like large scale data wrangling. So I'm going to be doing this stuff on Rivana, and this doesn't really work for me. Okay, I tried this locally, and this is what your output looks like. What you're going to see is essentially that table converted into just string values. So you can see you do have like a /r and /n for new line, /r for like spaces or something, white space. And so you can probably write a parser to take this and convert it to something more usable. But Python has a couple more options than R. So there's PDF Miner in Python. There's PyPDF2, which is an older, it's an older library. It's not really supported at the moment. And then there's TabulaPy, which is my solution that I've tested and it actually works. And I have my code in the Python file that's given to you guys. That's on GitHub actually. And on GitHub, I also have included this entire PDF file as well. So you guys should be able to try out and run the actual code that converts this to some sort of usable data format. So I'm gonna give you guys a minute. I'm gonna stop share here. I'm gonna share. Oh, I'm sorry. Can you go back to the code we need again? So the entire code is actually in the R file that is in the GitHub repo. So if you clone the GitHub repo, you have access to the code. It's the section 1. Which is up to this point. Cool. Again, I'm gonna take 5 minutes now just to let people try out. Actually, wait. Show of hands in the participants list. How many people got to this point where Miniconda was installed and 2, 3, 4, 7. Okay, cool. That's great. A decent amount of people have been able to get this working. Okay, so that's actually it's just 12 people. So I just wanted to ask if if you haven't been able to do this, can you throw up a no just in case? So I know for a fact that I'm not going too fast with this. Okay. I'm not seeing any no's in the participant list. So, okay, let's see. I mean, you can say no. This is actually pretty fiddly, and the fact that so many people got it all right is something I'm very excited about. Right. So, oh right. Yeah, I'm sorry about that situation because there's really no workaround for that for the spaces thing. You can create an. I just wanted to ask also. I'm sorry, I don't really want to. Mosa, if you could just mention the system that you're using. Are you using Linux or Windows or a Mac? Like, what are you using? If you can just drop that in the chat to see if we can figure out some sort of like workaround for that. Windows 10, Windows 7. Okay. Right. So I think the workaround here is you're going to have to use a different user account, which does not have a space in the name, because that is my issue. Like I have a space in my user account name, which is what messes up the path for Anaconda. Oh, sorry, Miniconda. And the other solution is, of course, to install Miniconda manually and then specify that specify the path specifically. So I'm just gonna pick up the so here's the Miniconda installation docs. In case you're getting into a situation where you can't actually have Miniconda installed by default, you're gonna have to do this manually, following the instructions in those in the docs essentially. And then once you're done with that, you can use a specific command, which is use _ Python. And then here you need to specify the Miniconda environment that you just installed so that your RStudio knows that that's the specific Python that you need to use when you're running reticulate code. Right. So just as a tester, this is what I like to do, where I've done timelib is import time, which is interesting. What I'm doing here is using the import function to just pick up the Python library time, and using that as an object in R. And that's, I don't know, it's kind of crazy. You can do this for any library, including pandas or NumPy or scikit-learn. But this is a great like example where here's the time function on Python, which is especially useful if you're trying to measure speed of execution. So epoch is timelib, and you use $ to specify the functions or subfunctions of that object. So that is saved into the, so that epoch value is essentially the time right now, except measured in epoch seconds. This is all essentially Python code, just saved into variables held in R. So in this, here's an example essentially of using Python code in R. You guys also mentioned the the using of, oh, I'm sorry, Grant has a question about, is the session going to be run in Jupyter or RStudio? And yeah, the answer is RStudio. Although I'm going to continue using Jupyter just because my RStudio is having issues. But that doesn't necessarily, so, but because the code is going to be the same, I don't see that being a problem for anybody. If anyone is having an issue though, please feel free to say something in the chat so that we can like take a look at it. Again, in your code, you should have the epoch time example as well, so you can give that a shot. And once you're done with that, I'd like everybody to try out the actual tabular code that's in the library as well. So if you guys can see my screen right now, I have one line of code here, which is about py run string. And okay, py run string essentially lets you run one line of Python code in R. So this essentially is using the tabular function or tabular library to read a PDF from a remote location. This is essentially a test of the PDF reading functionality in general. And so it's essentially an Arabic PDF, which it's extremely hard for usual for something like read text, especially like R, the R functions read text to be able to pick that up. But this is able to do that without much issues. Although you will still see some issues which aren't exactly. It's because the way this function works is it uses OCR to try and recognize the characters and then recognize words from those characters and puts that into a data frame. And you should also be able to see a result like this when you run the same command on the actual file that's included, that is the 2015 taxable land book. And you need to make sure you add the error bad lines false, because if you don't add that, it also kind of errors out and crashes the minute it reaches one bad line. And that's going to happen often in case you're looking at unstructured or relatively unstructured table data. So here's a much more usable version of our actual data set. So again, you are seeing issues like sometimes you're seeing column headings instead of column headings coming in as rows instead of actual usable values. And you see occasionally addresses split up across different lines. But this is a much more usable format than the original, which was just a blob of text. So I just want everybody to, okay, cool. Right. So that's the, so if you're seeing a file not found error, you're going to have to rename that, that string that refers to the file and be specific to the actual file in your directory. So, okay, for example, actually, yeah, exactly. Your clone might have a different file path. That is, thank you, Joanna. That is specifically the perfect way to describe why that error is coming up. Yeah. So as you can see, for me, I used just read PDF that because it's in the same folder as my file. So you need to make sure that your path, your file path, is relative to your actual code location. Hopefully that works for you guys. Although they should just work for you guys. Again, in case you've been able to get to either this point or this point, please do put up a yes. Okay. So I'm seeing some yeses, which is encouraging. But yeah, so this is essentially the methodology that you would use when you're trying to run Python code within R. So in case you're, I mean, the Python code syntax itself is something that I can't really teach in detail when we're going through this. We're trying to be essentially just giving you an introduction of how this interface works between R and Python. So I'm going to come back to my slides just to essentially bring up like situations, like when would you do something like this? Right. Oh, right. While I'm on the topic of using Python objects in R, this is the kind of conversion that happens behind the scenes when you actually try to call Python objects in R. So if you have a single element vector in R and you're converting it to Python, it gets turned into a scalar and vice versa. Lists become multi-element vectors. What's interesting is that pandas data frames get turned, like data frames get turned to pandas data frames. So if you're using a data frame in R and converting it to Python, you need to make sure you import pandas. The same thing for matrices and arrays. If you're using a matrix or array in R and you're importing it to Python, make sure you import NumPy. Otherwise, it's not going to work. This is where using Miniconda comes in handy because it already has NumPy, it already has pandas. So you would have less of a hassle getting these things to work. So again, this is, I'd like to emphasize, this is an edge case. I don't see this being used very, very often or very commonly. Like I don't see, this is something that can be done. And I'm not encouraging anyone to do this very often, especially in these situations where, okay, maybe you have specific data, data formats that don't actually have R support. Apache Avro is something that I've encountered where I've had to convert from the Avro format using like Python to something that can be used in R. Also, like R-based, like using Python makes sense for data processing tasks, which can get pretty big. Machine learning, neural networks, that's where Python is useful as well. And this is mainly, again, comes back to the community question, where there's a lot more people working on these kind of problems in the Python community at the moment. And that's why if you're looking for like really new tech or really new libraries on neural networks, the best resource is to use Python rather than R. And also, just neural networks in R is a little complicated because R is sitting on multiple layers. There's multiple layers of communication between RStudio to R, to C++, and to the actual machine code itself. And so running a neural network, which is already very intensive, and also doing the communication between layers, that seems unnecessary or time consuming. And so the general overview is that these are both tools that you have, and that you can use for a given situation. But just because you have access to it doesn't mean that you should apply it to every situation. I would actually recommend for most of the tasks that you're going to encounter in the DSPG, or honestly, in most like work contexts, it does make sense if you're not doing just a one-off. If you're using Python extensively as part of your workflow, it makes sense to have a separate Python environment and a separate R environment. And if you're trying to do so, and because some things are better done in R and some things are better done in Python, it makes sense to export data or export your results from each language to something that's more commonly usable. So how I try doing things is I do my data processing in Python, especially working with larger sets, and then I export that to smaller CSV files, which are more manageable for something like R to handle. And then I can use R for analysis stuff or stat stuff, and also for like data visualization stuff. And I don't necessarily need to have Python code sitting inside your R environment. But then if you're trying to do one-offs though, if you're trying to do situations where there's some sort of translation that you need, that isn't something that's part of your general workflow, but it's a workaround that you're setting up, that's where this kind of a flexible Python in R approach kind of works. The other thing I want to highlight is the concept of feather files. So feather is something that Hadley Wickham is coming up with, and I'm just going to share the page for feather. So essentially, it's a format that's designed for data frames between that's supported both by R and by Python. So, right. So yeah, it's Hadley Wickham and Wes McKinney working on this. And they've been working on it since 2016. They have a working library that's out there. It's not really a format that I've used extensively because I generally use CSVs or JSON files for interchanges. But this is, I would say, the next big thing for information interchange between multiple languages. And so, yeah, this is something to consider if you're in a situation where you have some tasks in a project that are better suited for one language than another. That's basically it from me. Like I said, this was a quick summary, and it's also an edge case, so it's not something that I expect everyone's going to use on a regular basis. But it is handy in those certain situations where you need this kind of functionality. If you guys have questions, you can let me know. Okay, I have an error. Error in Py. Wait, a last show of hands actually how many people have been able to get to the actual output with my tabular code? Okay. Uh, Not actually sure what that error is. What fella? If you'd like, we can actually work on that separately. If that's something you can, if you can just send me the entire. Handle is invalid wind error 6. Okay. Again, that's not something that I've seen before. Are we sure that it's the right file location that we specified? Uh, Watsala did running just pi d2, just pi $ df2. Did that work? Worked up to data, right? But it's not working for the second one. Okay. I think, so that's basically it from my session. But if you have errors, I would like you to stay on and we can actually share screen and try and work through them. But for everybody else, if you guys are all right with this so far, I think that's it from me. Thanks.